Hey guys, welcome to Unit 4, Day 2. We're going to solve and graph one-step inequalities. Those of you who loved last unit are going to love this unit. Those of you who didn't are going to get even better at it. So let's bring it on. Okay. Now I'm asking you to solve this inequality. I'm trying to find all the numbers in the universe that I can stick in this inequality that will make it true. I'm trying to find the solutions, and I solve it the same exact way as I solved equations. So let me illustrate one. Okay, so I draw my line down the middle. I'm trying to isolate h, so I'm going to add 3 to both sides. And I'm going to end up with h on this side, and notice how I made this constant 0, and I'm going to, instead of bringing down the equal sign like I used to do for equations, I'm just bringing down that inequality sign. And I end up with h is greater than 8, and I've actually solved this inequality. And so let's graph it and let's see what that means. So I'm actually going to create my number line. I know that 8 is going to be my endpoint. I know it's going to be open. Let's see if we can figure it out. I know it's going to be open because it's just greater than. So this is going to be 8. I'll make this 9. I'll make this 10. I'll make this 7. Now I'm trying to find all the values that are bigger than 8. Notice how it's pointing to 8, and 8 is on. So 8 is going to be on the small end of the solution. So let's see. 8 is smaller than all the values, and h is bigger than 8. Here we go. I'm graphing all the values that are greater than 8. I'm going to check one to see. I'm going to check one of the things that I've graphed. I've chosen to graph 10. I'm going to put that in there for h. 10 is greater than 8. Is that true? Oh, it's true. That means I know that I've graphed the correct side. Okay. Let's solve this the same way. I'm going to draw my line down. I'm going to try to isolate x. I'm going to subtract 7 from both sides. I end up with x is, don't forget to bring down your inequality, which is greater than or equal to, there's a wrinkle here, sorry. X is greater than or equal to, still a wrinkle, negative 7. So I'm going to draw my number line, and I'm going to make sure negative 7's on there, because that's one of my endpoints, so this will be negative 7. That'll be negative 8, negative 9, 6, negative 5, and one of my endpoints is negative 7. Now, should that be open or closed? Is negative 7 a solution? Let me see. Yeah, that's true. So that means that negative 7's got to be included. And I know that anyway because there's equality. And I'm looking for all the values of x that are greater than or equal to negative 7, all the values that are bigger than negative 7. And those are the ones to the right of my endpoint. Four is less than or equal to w minus 1. So I'm going to add 1 to both sides. I end up with 5 is less than or equal to, make sure you bring that inequality down, w. So I know that 5 is an endpoint, so I'm going to graph 5. And I know that 5 is included in my solution set because there's equality here as part of this statement. So that's included. That means 5 is a solution. That means I can put 5 in there and it'll be true because it's true that 5 is less than or equal to 5. Now I've got to figure out whether I need to graph the right or the left side of 5. Well, this tells me that 5 is less than or equal to w. 5 is going to be on the lower end of the solution set. You can see it's pointing to the lower end. So that means I'm going to graph everything that's greater than 5. Let me go ahead and check. Let me pick, I'll just pick 7 because that's just one thing that I've chosen to graph. Let me see. Is 5 less than or equal to 7? Yeah, that's true. That means I know I've graphed the right side. Negative 8 is greater than or equal to t minus 11. So I want to isolate t. I add 11. I add 11 to both sides, and I end up with 3 is greater than or equal to t. So let's graph our endpoint. I'll make that 3. That'll be 2, 1, 4, 5. I know that my inequality actually includes equality, so when it's closed. Okay. Now looking at this sign, greater than or equal to, my value 3 is on the big end of that. 3 is bigger than all of the answers, all of the solutions. So I'm going to be choosing everything that's smaller than t to graph. And you can see that 0 is one of the possibilities. So let me check that. Is 3 greater than or equal to 0? Yeah, that's true. So I know I've graphed the correct side. I want you to try this one. Pause me. I want you to try this one. Pause me. Okay. Now we're going to see what happens when we're not just adding or subtracting to x, but when we actually have x multiplied or divided by something. We're going to use the same rules that we use for equations. So we're trying to isolate x. So x is multiplied by 3, so I'm going to divide by 3. I'm going to divide by 3. Wow. And let's see, I end up with x is greater than or equal to 2. And x is isolated. I found my solution. So let's go ahead and graph it, and then we'll test it. I'll make this 2. So that means that's 1, and that's 0, and that's 3, and that's 4. And let's see, does 2 work in that inequality? Yeah, 2 works. I can tell anyway because there's an equal sign. I know it's going to be closed. It's a closed circle. And now I'm looking for all of the values on this number line that are greater than or equal to 2. All the ones that are larger than 2. And these are all the numbers that are larger than 2. I'll test it out. I'll test it out with 4. That's one of the ones that I've shaded. So let's see. Is 4 greater than or equal to 2? Yes, it is. That means I've shaded the right side, the correct side of my endpoint. Ooh, a divided by 4 is less than 1. Here we go. So I want to get a by itself, and right now it's divided by 4. So I'm going to multiply by 4. That's the inverse operation. If I do it to one side, I do it to the other side, and I end up with a is less than 4. A is isolated. I've solved my inequality, so let's go ahead and graph it. I'll make that 4. And so that's 3, and that's 2. That's 5. Now let's see. Is 4 included? Is that going to be open or closed? Well, let me see. If I put 4 in there, is that true? No. That's not true. That tells me that 4 is not included in the solution set. That means that circle is going to be left open. And I'm looking for all the values of a that are less than 4. I'm looking at this less than sign, and this tells me that 4 is on the big part of the solution set. It's the highest part of the solution set. So I'm going to shade in all the values that are lower than it. Okay? All the values that are lower than 4. And this arrow here means that the solution set extends all the way down to infinity, negative infinity rather. Okay? Love fractions. Here we go. So I want to get b by itself, isolate b. So, but it's multiplied by 2/3, and I really wish it was a 1. Yes, we'll multiply by the reciprocal. Multiply both sides by the reciprocal. Put this over 1 if it makes you happy. These will divide out, and I'll end up with b is greater than 6 divided by 2, which is the same thing as 3. a 3 there. I'll make that 4, 5, 2, 1. And here we go. So I'm looking for all the numbers that are bigger than 3. So does that include 3? Is 3 going to be left open or closed? It doesn't include 3, so 3 is going to be left open. I'm looking for all the values that are larger than 3. 3 is on the lower end of the solution set. You can tell because it's pointing to the 3. That means it's on the lower end. There you go. You try this one on your own. And pause me. You try this one on your own. And pause me. You try this one on your own. And pause me. Now for the good stuff. I'm so excited. Okay, let's think about what this says. This says negative 2x is greater than 4. I'm going to actually, let's see if we can come up with some numbers that'll make this true. Let's see, if I put 0 in here, will 0 make it true? Let's see, negative 2 times 0 is 0. Is 0 greater than 4? No, that doesn't work. Is 1, let's just try 1. Is negative 2 greater than 4? No, that doesn't work. Let's go the other way. Let's try negative 1. That gives me, is 2 greater than 4? That doesn't work. Let's try negative 2. Let's see. Is 4 greater than 4? No, that doesn't work. It's pretty good, pretty close though. I know I'm going the right direction. Let's try negative 3. Is 6 greater than 4? Oh, yay! Okay, we got our first answer. What we think. So basically, I think that you can tell by looking at this that anything that's going to be less than negative 2 is going to make this equation true. Let's see what happens when I try to solve. Okay, let's see. Divide by negative 2, divide by negative 2, and I end up with x is greater than negative 2. But wait a second. I think we just discovered over here that it's really anything that's less than negative 2 that's going to be my answer. The reason for this is when we divide by a negative, we have to flip our inequality. So whereas we had greater than, now it's going to become less than. That's what dividing by a negative does. So whenever you're dividing or multiplying by a negative number, you actually can't hear this, but I'm actually going to make this lion roar. I can hear that. I'll show you in school, okay? Whenever you are multiplying or dividing by a negative number, you need to learn to flip this inequality. So instead of greater than, it's going to become less than. So that's my solution. So I'm going to put negative 2 on here. And my answer is negative 2 is on the larger side. This is a larger part of the solution set because x is less than it. And there's my solution set. So here we go. So when you're multiplying or dividing an inequality by a negative number, you're going to flip the inequality. When you are multiplying or dividing by a negative number, you are going to flip the inequality. What is that? You know what that is? That's the word flipped. Flipped. You're going to flip the inequality. And in school, I'll tell you how all these guys sound, because whenever you're multiplying or dividing by a negative, I want you to think of a tiger. I want you to think of a crocodile. I want you to think of a rhinoceros. I want you to think of a siren. Woo! That's an alarm for you to say, I got to flip the inequality. Warning sign should go off in your head. Okay, let's see what happens. All right. So, here we go. I'm going to divide by negative 3. I'm going to divide by negative 3. Bam! You should be freaking out here. You should feel a warning going on here. So what do you think we're going to do here? We're going to flip the inequality. So instead of it being less than, it's now going to become greater than. greater than -4. Here we go. So I'll just graph it the same way. -4, -3, -5. I'm looking for all the values that are larger than -4. It's going to be open because it's just greater than. So all the values that are larger than -4 are on this side. Okay? You can see by this by who the arrow is pointing to, it's pointing to the smaller value. It's pointing to the smaller value. So this kind, -4 is a smaller value. Ooh, I see a lightning bolt. You know why? Because I'm about to divide. I'm about to multiply by a negative. I'm so excited. So here we go. So in order to isolate k, I'm going to multiply by -2. I'm going to multiply by -2, and I end up with k is less than 2. There's my answer. Oops, yeah, k is less than 2. You can see that 2 here is the larger of all, is the larger endpoint, so it's higher than all the values of k. Okay, so that's why I've gone to the left of 2. Okay. Last one we're going to do is -2/3 s is greater than or equal to -4. So let's see, in order to get s by itself, I'm going to multiply both sides by the negative reciprocal, the reciprocal, which is -3/2. -3/2. Did you see that? Did you see we're about to divide by, or we're about to multiply by a negative? So that means we're going to do what? We're going to flip the inequality. So we end up with s is less than or equal to, I end up with 12/2. So s is less than or equal to 6. Did the hackles go up on your back? So here we go. 6. Let's see what that looks like. This is 5, 4, 7, 8. And s is less than or equal to. So since there's equal to, I'm going to color that 6 in. And 6 is going to be on the larger side of my solution set. And I'm going to get all the values of s that are less than or equal to 6. Okay, you try the next one. You try the next one. You try the next one. Okay. Anybody who turns their paper over and draws a really cool picture to help people remember that if you divide or multiply by a negative, warning, 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 danger, danger, that you have to flip, I will put those pictures up and you will get a Jolly Rancher. Okay, I'll see you in class.